Scholars, Ms. Perez again here with our new physics lesson. Today we are going to be covering Unit 5, Lesson 10, Predicting Interference of Waves. And just like I normally do, I am going to share my screen with you all so that you know the tabs that you should have open. So in Google Classroom, you are going to access this document where we're going to be doing our classwork from. This reading is also linked onto your Google Classroom, and then you should have the Simplicity of Science website as well to access anything else that you might need. All right, so let's start with our lesson. Predicting interference. Again, the materials that you should have are your calculator, a notebook, a pen, a pencil, and if you have graphing paper at home, you should use it today. It's going to be really helpful for when we do the exercises at the end of the day. If you don't have graphing paper, it's not a big deal. I might recommend using a ruler to be able to solve these problems to make things a little easier for you. Alrighty. So yesterday we discussed superposition and we defined interference and its two types, constructive and destructive interference. Today we are going to look at what happens when waves are in superposition and are actually interfering with each other. And we're going to develop and use models to represent what these interactions between two waves actually look like. So let's start with our do now. Thinking back to what we learned yesterday and what we know about interference, you're going to sketch a prediction about the interaction between wave pulses A and B. Your first sketch will be while the waves are experiencing interference, and B will be after, your second sketch will be after the waves have crossed their paths. When I say press pause now, take the next 2 minutes to complete the do now in your notes. When you are done, press play again. Press pause now. Great, welcome back. Today's activity is going to be a short reading and then practice problems. So you're going to take the next 5 minutes to complete the reading. Make sure you look carefully at the example at the bottom of the first column. And then add that example into your notes. It is important to consider what is happening before, during, and after wave pulses meet. What happens when the wave pulses meet? And consider how a wavelength is affected and how the amplitude is affected. So just so that it's clear, in your work here, in your work document, there is a link to the reading, which you should have open already. You're going to keep in mind these guiding questions as you read, and then you're going to take 5 again. Then you can just follow these instructions. Right. When I say press pause now, take the next 5 minutes to complete the reading and copy the example at the end of the reading in your notes. When you're ready to come back, press play. Press pause now. Great. Welcome back, scholars. From your reading, you should have caught these key points. Take the next 2 minutes to copy these into your notes. I'll read them out as you're writing. So the principle of superposition states that when two waves of the same kind meet at a point in space, the resultant displacement at that point is a vector sum of the displacements that the two waves should separately produce at that point. That's a mouthful of a definition, and it sounds like a lot. So in simpler words, when two waves meet, waves are either going to add or subtract based on their displacement. And then based on the model of the two waves, we can predict when and how the two waves will interact and interface, will interact through interference. To we're gonna also keep this principle in mind that you have on your screen while we're completing the practice problems. This is basically a visual summary of the key points and from your reading. When you have two pulses that come together and have upward displacement, they add up. So each amplitude adds up together. So then you'll have here, this is 1, then you end up with a 2 amplitude wave. And the same thing happens here is even though my amplitudes are negative, they're both negative, so they add up to have a negative amplitude. But then in the case here where you have destructive interference, there is an upward pulse and then a downward displaced pulse. And they both have the exact same amplitude. So because one's positive and the other one's negative, at that position, they're going to momentarily cancel themselves out. Right? So keeping this in mind, we are going to solve, I'm going to model a problem for you, and then you're going to use this model to complete the remaining problems from your classwork. By seeing me solve this problem, it will be helpful for you to complete the other problems in your reading. Right, so as I am writing this down, please take notes of this in your notebook. All right, so the first thing we're going to do is I have a little piece of graphing paper here. I am going to choose a scale. So I'm going to say that each one of these squares is going to be 1 centimeter long. That's going to help me draw my pulses as accurately as possible. Be a little patient with me here as I draw. It can be a little hard using this kind of technology, so that the lines aren't going to be perfectly straight. So I have, right here we have a pulse that's moving towards the left, and then we have this pulse that's moving to the right, and this one's moving towards the left. So I want to know what this pulse is these two pulses are going to look like at the point where they're at the same place at the same time. So they both have the same height, but they have different widths. So when they're at the same place, basically this pulse here that's smaller is going to be kind of like on top of this pulse here that's bigger. So I am going to draw out what that looks like first. So I have my flatness here, and then I said I'm going to draw this pulse. Each one of these squares is 2 centimeters. So that's my height. And then I have 1 centimeter this way, and then 3 centimeters total, and then come back down. So that's the pulse. So I'm going to call this one pulse 1, and this will be pulse 2. So here I have my first pulse. On top of this, I'm going to draw my second pulse. So because they're in the same place, it's going to be directly in the middle, and it's going to be 2 centimeters high, but it's only 1 centimeter in width. So then this is my second pulse. So that's what they're going to look like. I am going to draw this out one more time, but drawing it out together. So I have my 2 centimeter, oops, so it's not so pretty. So here I have my 2 centimeter height. So I'm basically just copying what I had on top. But except it's all one pulse now, so there's no separation here. Yeah, it doesn't look so great, but you guys get the general idea. So this is what the pulse will look like at the moment that there's superposition. If you have any questions about this or how I got this, please take notes of it into your chat or ask your teacher now. So keeping that in mind, you are going to take the remaining of the class to solve the rest of those superposition problems in your notebooks. Then you are going to complete the exit ticket that is in the Unit 5 Lesson 10 classwork document. You'll complete that in the document itself. By the end of this period, please submit your Google document and the pictures of your notes. If you have any questions, let your teacher know. I am going to go over the doc one more time so that it's clear here where you're answering everything. This do now should be completed in your should have been completed in your notebook. You're answering the problems B through E in your notes, and then you are going to answer these two questions as your exit ticket in this Google document. Great. Have a great day, everyone.